Let's talk about balancing equations. An equation is used for when a chemical reaction has taken place, and it represents the compounds and elements that have reacted together and that have broken bonds and made bonds and produced products. And so the general reaction here is that reactants yields products. And we use this little arrow to represent yields. So it's saying that our reactants have reacted together, bonds have been broken and reformed, and we get new products as a result. And when you're balancing equations, you need to have equal amounts of elements on each side. And this will fulfill the law of conservation of mass. So this is a step-by-step how to balance equations. Sometimes I think it's just easiest just to do it. But let's go ahead and go through each one of the steps. So number 1, write the name of the reactants and products. 2, write the skeletal equation. So how do you do those formulas? So remember, use oxidation numbers if there's a metal, or you just write how many it tells you to write if you have those Greek prefixes with non-metals that are bonded together. Then when you go to balance it, you're going to put numbers or coefficients in front of the whole group to increase the number of the elements. And oftentimes hydrogen and oxygen can appear multiple times in a chemical reaction. And so those tend to be a little bit more difficult. And so usually you want to save those for last. Step 5, add the states of matter. So S for solid, Cr for crystal or a crystalline solid, L for liquid, G for gas, AQ for aqueous, which means that it's dissolved in water. And then you're going to double check. All right, so here's an example. So we're going to take hydrogen and oxygen gas and react them together, and we're going to form liquid water. So the first thing you're going to do is write down the symbols of these elements, hydrogen and oxygen. So hydrogen, remember, is diatomic. So there's 2 of them. It always has to have a buddy. In this case, it's buddying up with itself. So hydrogen combines with oxygen. Oxygen is also diatomic, so you have to write O2. Anytime you see hydrogen and oxygen in your reaction, you need to write it as a diatomic molecule. And it combines to form liquid water, which we know is H2O. So that's the first step. So we just write what we have. The second step is to take note of elements on each side. So on this side I have 2 hydrogens, and on this side I have 2 hydrogens. So I'm good. I don't need to do anything there. Let's look at oxygens. On this side I have 2 oxygens, and this side I only have 1. Now I can't put a 2 there because I would have changed it to hydrogen peroxide, and that's not what we're forming. We're forming water. So don't ever, ever, ever put small numbers like that, okay, when you're balancing. Instead, you're going to put a big number in front like this, okay? So this, I will say, I have 2 times the O, or the oxygen, so I have 2 oxygens on this side. Now by doing that, I messed up our number of hydrogens. That's not balanced anymore. So here I have 4 hydrogens because 2 times 2 is 4. And then on the reactant side, I have 2, and I'm just going to put a 2 in front. Okay, so this should be balanced, but let's go ahead and double check. So 4 hydrogens on this side and 4 hydrogens on this side. And we have 2 oxygens on this side, and we have 2 times 1, 2 oxygens on this side. So this is balanced. All right, I'm just going to erase all of our little double checking here just to clean it up. And our last thing is to do states of matter. Now, chemists are very lazy, and they typically don't put the states of matter. And so I am not going to require it for you to do it, but I'm going to at least show you once what it looks like. And also, if you see these little G's and little S's and little AQ, you will know what it means. It just means the state of matter. So I have 2 gases that I have reacted, so I just put them in these little parentheses, and I get liquid water. So now this is correctly balanced, and it's complete because we've added the states of matter and we've double checked. Here is a picture description of the reaction that we just balanced, and I just want you to be able to visualize what's going on here. So here we have 2 molecules of hydrogen, so it's represented by the little blue circles, and then I have 1 molecule of oxygen represented by the red circles, And then notice that when we come over here on our products, we make 2 water molecules. And you can see that we still have 2 red circles and 4 blue circles. And so this is that conservation of mass. So we didn't create nor destroy any atoms during our reaction. Let's practice balancing some of these equations. Again, I'm not going to put the states of matter, I'm just going to balance it. So let's look here on our first one. So we have methane, CH4, and looking here, there's a lot of oxygens and hydrogens. I'm going to save them for last, so I'm going to just concentrate on the carbon. So I do have equal amounts of carbon on each side, so I don't have to do anything there. I think I'll just go left to right. So on this side, I have 4 hydrogens. And on this side, I only have 2. So I'm going to put a 2 in front of everything. So this gives me 4 hydrogens on each side. Let's count our oxygens. So here I have 2 oxygens here. And over here I have 2 oxygens plus 2 times 1, 2 oxygens for a total of 4 oxygens. So I just need to put a 2 in front there to make this now 4 oxygens, 2 times 2. Okay, so this should be balanced. Let's go ahead and double check it. Let me just kind of clean things up here. So we have 1 carbon on the left, 1 carbon on the right. We have 4 hydrogens here, and here we have 2 times 2, 4 hydrogens here. And look at our oxygens. We have 4 oxygens here, and on this side we have 4 oxygens here. So this is balanced. Let's look at the next one. So we have our aluminum, and it looks like it's all by itself, and I think I'm just going to start there. So we have 1 aluminum here, but I have 2 there. So I'm going to put a 2 on this side. So that balances that. Let's look at our barium. So 1 there and 1 there. That looks okay. And let's look at oxygen. 1 oxygen there. Oh, but I have 3 right there. So I'm going to have to put 3 in front of this oxygen so that I can have 3 oxygens. So let's see, is it balanced? Oh, but that changes our barium. So we need to go back and put 3 in front there. So let's double check that we have everything. So we have on one side of the equation 2 aluminums, on the other side 2 aluminums. We have 3 barium, and over here 3 bariums, and then oxygen. We have 3 oxygens here and 3 oxygens here. So this is balanced. Here is a pictorial representation of that first one. So we have, again, you can see the black carbon. There's 1 on each side, and we can see our oxygens are the red circles, and we can see that there's 4 on the left and 4 on the right. Here's some more. Let's go ahead and quickly balance these. So I think I'm going to start with my nitrogen. So I have 2 nitrogen on the left, so I'm going to put a big 2 in front here. That gives me 2 nitrogen. Let's look at our hydrogen. Our hydrogen, I have 2 hydrogens on the left and 2 on the right. And let's look at our oxygen. I have 2 times 2, 4 oxygen here. And over here I have 4 oxygen because I have the 3 plus the 1. Now notice that the ones aren't written, but when you're counting them, they are there. Okay. All right, so that's balanced. We just had to put a 2 right there. Let's look at the next one. So more aluminum. It looks like I have 1 aluminum on each side. So that looks okay. My lead looks okay. And let's look at our nitrate. So notice this polyatomic ion stays together. So let's look and see how many we have. We have 2 nitrate on this side and 3 nitrate on this side. So as it's staying together, I can just count it like a single thing. So I have 2 nitrates on one side and 3 on the other. So what number does 2 and 3 go in together? What number does 2 and 3 go into? And it would be 6. So I'm going to bring this one up to 6 by putting a 2 in front. And I'm going to put this one up to 6 by putting a 3 in front. Now this changes my aluminum and my lead. So I just need to go back and balance that. But that should be balanced now. And we can go through and we can count nitrates or we can count nitrogens. Let's go ahead and count it by atom. When it stays together, I like just to keep it together. All right, so 2 aluminums on each side, 3 leads on each side. I have 2 times 1 nitrogen, which is 2, and then times 3, I have 6 Ns on this side. And here I have 3 times N times 2, I have 6 Ns. And let's go to oxygen. I have 2 times 3, I have 6 oxygens times 3, I have 18 oxygens. Woohoo! And over out here, I have 3 times 3, I have 9 times 2, I have 18 oxygens. So this is balanced. Let's look at our very last one here. Now notice on this one, our polyatomic ion does not stay together. So we would have to do just like what I was teaching you up in that middle problem, how to count the atoms in the polyatomic ion. So let's start off with the most logical. So I'm going to save oxygens and hydrogens for last. So start with the iron. So I have 1 iron here and I have 2 there. So I'm going to put a 2 in front. And let's see what that does to our oxygens and hydrogens. I think I'm going to just go to hydrogens because it's only in one place on the right hand side. There's only one formula that has hydrogen in it. How many hydrogens do I have on the left hand side? So I have 3 times 1, 3 times 2. I have 6 hydrogens. So over here I want to put a 3 in front to give me those 6. 3 times 2, 6 hydrogens. Okay, let's look at our oxygen. So we have 3 times 1 times 2. I also have 6 oxygens on this side. And over here I have 3 oxygens, and over here I have 3 oxygens. Okay, so this is now balanced. 2 irons on each side, 6 hydrogens, and 6 oxygens on each side. All right, let's look at this where we have to write the formula. So this is a combination of what we've learned previous, and then we're adding it to balancing equations. So remember to use oxidation numbers if you have a metal. So you can't do it in one step, you need to do it in 2 steps. So let's do this first one, aluminum hydroxide. So aluminum is a +3, hydroxide is a polyatomic ion, and it's OH minus. I need to have 3 of these to give me that -3 charge. So I'm going to end up having AlOH3, okay? And I'm going to add it to the next one, sodium nitrate. Sodium is a +1. Nitrate is a polyatomic ion. It's a -1. And so I can just put them together. And I do not need parentheses around the polyatomic ion because I just have one of them. And then the rest of these, the reactants are going to recombine in a new way. So I already know what aluminum looks like because it's right there. Okay, it's Al3 plus. And nitrate, I already know what nitrate looks like because it's right here. Okay, let's see, how do I put this together? An Al +3 and an NO3 minus. I'm going to have 3 of this guy. So Al, and then in parentheses, you want to keep the polyatomic ion together, 3. So it looks a little weird. NO3, 3. That is correct. Okay. And do this next one. Sodium is a +1 and hydroxide is a -1. So I can just stick that one together. NaOH. All right, let's go through and let's balance it. All right, so I'm going to start with the aluminum. It looks like our aluminum looks okay. And it looks like our sodium looks okay. So let's look at the polyatomic ions. So this polyatomic ion has 3. And so I need to make sure I have 3 on this side. So 3 OHs on that side. That messes up my sodium, so I'm going to put a 3 in front of the sodium. Let's see how that changes the nitrate. I have 3 NO3s. Oh, and then I have 3 NO3s there. So this is balanced just by putting those 3s right there. Okay, let's do some more practice. So we have magnesium metal. So this is just element magnesium. And whenever you have elements, you just put their symbols down. You don't need oxidation numbers unless you've made a compound. So if they just say lead or they just say zinc, that is just the metal. So you just put the symbol down, okay? Manganese, so manganese is Mn, and then look, there's that 3 that always goes to the metal. So this is manganese 3 plus. Oxide, that is a 2 minus. So how do I put that together? I'm going to need 2 of the plus 3s and 3 of the minus 2s. So there it is. And let's just go ahead and bring that magnesium down. Okay, so notice that we're doing this in 2 steps. Okay, all right, next we have magnesium oxide. So now magnesium is in a compound. So I need to use oxidation numbers. Magnesium is an alkaline earth metal, so it's a +2 always. Oxygen is a -2, so I can just stick that together. A +2 and a -2 will cancel out. And then I'm left with manganese metal. So that's just the symbol, just like that. Okay. Is this balanced? No, it doesn't look balanced because I have 2 manganese right there. So let's go ahead and put a 2 in front of the Mn on the right hand side. And now let's look at our oxygens. I have 3 oxygens there and only 1 there. So I'm going to put a 3 in front of that whole compound. Okay, so one error sometimes I see students make is they'll put the big number in the middle of the formula, and that is just gobbledygook. Don't do that. So it always goes in front of the whole thing. Okay, that messes up my metal magnesium, so I'm going to put a 3 right there. So now it is balanced. Okay, let's do the next one down below. So again, use oxidation numbers. So we have sodium hydroxide. So sodium is a +1. Hydroxide is a -1. So I can just stick that together. NaOH. And I'm going to add it to hydrogen sulfate. Now remember, if it ends in an 8, that is a polyatomic ion. So hydrogen ion is a +1. And sulfate is SO4. And it's a -2. Okay, so how do I put that together? I have to have 2 hydrogen ions. So this would be H2SO4. Okay, I'm calling it hydrogen sulfate here. It's also can be named as an acid. This is sulfuric acid. This on our product side. So we have sodium sulfate. So sodium is a Na+, and sulfate is SO4 2-. So again, I'm going to have 2 of the cation to go with the anion. So this is going to be Na2SO4. And then water. So some molecules have a common name, and so water is H2O. So let's see if it's balanced. So I see 2 sodiums there, so I'm going to put a 2 in front of there. And let's see what else we have. It looks like our sulfate stays together, so I have 1 sulfate on each side. And then on our hydrogens, let's count our hydrogens. So we have 2 hydrogens plus 2 hydrogens. I have 4 hydrogens total. And over here I only have 2 hydrogens, so I'm going to put a 2 in front of there. That will give me my 4 hydrogens. Now let's come to oxygen. I'm just going to keep my fingers crossed that I have enough oxygens that I don't have to do anything crazy. So let's see, I have 2 oxygens here, and I have 4 oxygens in the hydrogen sulfate. So I should have 6 oxygens. Whoops, I goofed. That's oxygen. So 6 oxygens on that side, and let's see on this side. I have 4 oxygens plus 2 oxygens. Yay! I have 6 oxygens. So that is balanced. So here is my balanced reaction. Okay, so notice when I balance, I use the larger numbers that go in front of the whole compound. The little subscripted numbers, those are for when you're putting the molecule together and you're saying you need more than one of an element or a polyatomic ion.